All right, here we go. Welcome to lesson 7.5 notes, solving rational equations. Last lesson of chapter 7. Like a lot of the last lessons, it finishes with solving some equations. We'll look at basically two kind of styles. There's anywhere from fairly basic to um, kind of tough, honestly. So we'll hit them all here. As always, trying to keep the video short, jumping in, getting going. So let's take a look. First thing, first situation that we're coming across, basically, I guess when it's even just looking at the beginning, when it says solving rational equations, you're basically solving equations that involve ratios or fractions on both sides. So um, situation one basically is you've got a single fraction on the left side like we have here. We've got a fraction equal to another fraction. All right, so this is something that I know gets done a lot in previous courses. Probably the easiest thing to do is cross multiply, because if these fractions are truly equal, which it says they are, their cross product should be equal. Even a more basic example, I think everybody knows that 1/2 is exactly the same thing as 10/20ths, right? Those are equivalent fractions. So their cross products, when I multiply, 20 times 1 is 20, needs to be equal or should be equal to the other cross product, which is 20. So that's kind of the premise behind what we're doing here with even this first example. This is more of an in notes example. Um, so that's what we're going to do. And again, even here, these particular problems with cross multiplying, this one I think is a more of a basic, but we can definitely it can level up a little bit. So here we go. Let's solve this. 3x over 11, or I'm sorry, negative 3x over 11 equals 15 over 27.5. I see this fraction on the left side, fraction on the right. What's my approach? I usually start with the x. Doesn't necessarily matter. I'm going to my calculator just to double check. 27.5 times negative 3. I've got negative 82.5. X is equal to my other cross product, 11 times 15, which is 165. Sweet. After that, we've got what left? Divide both sides by negative 82.5 to get x equals negative 2. So, yeah, these are all checkable. The one thing we'd want to look out for, I don't even know if we'll add it necessarily to the notes, but on your checks, how would I know if my answer is good? You plug it in. And even here, we'll kind of just verbally check a few. Some can be kind of tricky as far as doing it all in your calculator. But I would plug in my negative 2 wherever I have an x. Here it's just the one spot. And just make sure whether you want to recheck with your cross products or just divide the fractions out. What would we get? We would get 6 over, if I plug in a negative 2 right here, I'd get 6 over 11. So I might take my calculator and just say, hey, what is 6 divided by 11? All right, I got 0.54545454. And then I just double check the other one. What's 15? I'm checking this one now on my calculator. What's 15 divided by 27.5? 0.545454. So that's probably the easiest way to check these equations, or to check your solutions to these equations, is plug it in and just kind of divide out the fractions to see what you get. The one situation that we can't have would be plugging an x value back in, or plugging a solution in and creating a 0 in the denominator. All right, we've talked about that in previous lessons where you're just dividing by 0 is undefined. So if I would, it's not even an option here, but if there was maybe I solved the equation and there was an x plus 2 equals blah, 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 and I go to plug this in right there, I'm going to create a 0, which we would have a divide by 0 error. So that's kind of the one thing that we might have to take off, and that'll come up here as part of a few of our examples. Okay. All right, let's level up a little bit here. You pause, get them set up. Again, just keeping the video reasonable here. I'm going to just start by solving these two. Solve rational equations by cross multiplying. So on the left, what are we looking at? I've got two fractions. It's a perfect candidate for cross multiplying. You've got x's in the denominator on both denominators. What do I do here? It's the same idea. The big thing here to make sure we're doing is when I do this cross product, I need to make sure I distribute that 5. The whole quantity, 3x minus 5, is getting multiplied by 5. So I'm going to end up with 15x minus 25. And that cross product should be equal to, going this way, same concept, 20x minus 40. All right, you're left with something that's very solvable. I've got, let's see, I'll subtract the 15x and bring it this way to get 5x. And I think maybe on the same step, even I'll add my 40 back over to this side and get 15 and finish up by dividing by 5. X equals 3. So same idea there, plug it back in, check. Even if it's just a mental type of deal here, 5, and the one on the right's a little easier. 3 minus 2 is 1, so 5 over 1. Let's see, is that the same thing as 9 minus 5 is 4, 20 over 4? Yep, checks out. That's the equivalent to 5. Okay. All right, next one. Kind of sectioning it off here. Similar idea, you got x's all over the place, right? 1 over 2x plus 5, x over 11x plus 8. So x is everywhere. Doesn't really change our approach, right? If I go this way first, 11x plus 8, I'm distributing there at 1. But then going this way, I'm going to end up with 2x squared, 2x times x, and then 5 times x, which is 5x. Okay, so a little different here. That x squared is making me think we're going to have to factor this. Let's bring everything over to the right. So I'm going to subtract an 11x from both sides and an 8 from both sides. So minus 11x and then minus 8. Leaving us a 0 over here. 2x squared. 5x minus 11x is negative 6x. And the negative 8 is just showing up as it is. Okay, we can factor that. It's actually, why don't we start by dividing everything, both sides of the equation, by 2. Shrink this up a little bit. So now 0 equals x squared minus 3x minus 4. So this is where we're looking for combinations of numbers. So a little space here that multiply to negative 4 that add up to negative 3. So not a ton of combinations there. I think we're thinking of 4 and 1. Now I got to mess with the signs a little bit here. We're going to need the 4 to be negative and the 1 to be positive. Okay, so that should re-multiply back out, x squared, negative 3x, negative 4. So my solutions, plural, are x equals, what makes each of these 0? 4 and negative 1. So it is very, very possible to get 2 solutions and both work. I feel like a lot of the recent chapters have had extraneous solutions where we would always take off. It seemed to be the negative answer. But if we come up and look, barring one of these creating a 0 down in the basement, which does happen from time to time, negative 1 gets plugged in here. That's really the one thing that I'm just kind of going to do in the video here is check to make sure we don't create a 0 downstairs. So if I plug in a negative 1, you get negative 2 plus 5, which is 3. What happens when this is negative 1 over here? You get a negative 11 plus 8, which is negative 3. Right? We'd have a negative 1 upstairs, so they're going to be opposites there. I think we're okay. And then the 4 here, let's see, 4 times 2 is 8 plus 3, plus 5 is 13. 4 times 11 is 44 plus 8, 52. I think we're okay. Right? I think we're going to end up, we don't create that 0 down in the denominator. All right. So a little bit level up, some factoring involved there. That should be hopefully fairly fresh in our heads from the previous several lessons in this chapter. One more here. It's a little bit different looking on the start. So it says, this is kind of a weird heading, solve a rational equation with one solution. We just solved one that had 2 solutions. So kind of a weird example too, but this one doesn't look like the previous couple, right? Because how do I cross multiply when there's 1, 2, 3 fractions, 11x, 13, but what's going on here? So this is one initially is not something that we can cross multiply, but it's simple enough to combine 2 of these fractions and make a cross multiplication situation. So here's what I'm talking about. I'm looking at this denominator right here, and this denominator and seeing those are the same. We were coming off a previous 7.4 lesson where we were adding and subtracting fractions. Well, the whole reason we were doing that is for a situation like this. Why don't I bring this 8x, or I'm sorry, 8 over x to this side of the equation? Now, how do I do that mathematically? I have to subtract an 8 over x from both sides. So 8 over x minus 8 over x disappears over here. I have 11 thirds on the left. But now here's the spot we've seen recently. Negative 14 over x minus 8 over x. They have like denominators or common denominators. I can go ahead and subtract the numerators. Negative 14 minus 8 is negative 22 over x. And I've kind of forced now a much simpler maybe situation where I can say, hey, I can cross multiply here and use the cross products. So 11 times x is 11x. Negative 22 times 3 is negative 66. We'll divide everything by 11 to get x equals negative 6. Cool. So those are all situations when cross multiplying is going to be your best bet. I think most of the year students are really solid with cross multiplying because it gets done in geometry a lot, gets done in algebra 1. So you're solid there. It's a good skill that we can carry over to advanced algebra. Second situation, look at that. Holy cow, we got one situation, two examples. Now these last two are a little tough, but we can get this done here. What happens when so just a small section in your notebook, what happens basically when we can't create that proportion, or it's not, I feel like most of the times you could do it, but sometimes it's more work to try to force a proportion than what I'll show you here in this section. So it actually goes back and it ties back to that skill we were using in the previous lesson to simplify complex fractions. And I'm not sure if you remember that, but we were multiplying all of the fractions by the least common denominator. And what that did for us was essentially cancel the fractions. It kind of just got rid of the fractions. You were able to just work on with the numerators. And that's exactly what we're going to do here. Okay, so I'll show you it again if you don't remember from 7.4, but it's that same skill of identifying the least common denominator and using it. I called it the universal denominator in the video. Same thing. What's the universal denominator, least common denominator, kind of using those interchangeably. So let's take a look. All right. So it's giving us a hint here. We're going to get two solutions, but let's see what happens. What makes this one a little bit tougher? Well, hopefully we're looking at this seeing like, all right, this 2 here is really messing things up. If this wasn't here, we could cross multiply, but even that would be kind of nasty. This 3x minus 5 times this x minus or plus 3 minus 4 going this way. So it's a lot tougher to force a cross multiply in this situation. So let's do this. Let's identify the universal denominator or the lowest common denominator of these three fractions. And basically how you do that is you just go denominator by denominator and say each thing has to get represented here. Okay? So let's start with this one. This one's got the most going on. This one has an x plus 3 and an x minus 4. There's no getting rid of that. That has to be a part. I'm going to switch it, just write it the way it's written. But that has to be a part of the least common denominator. Okay. Let's look at this one. 1. That's the denominator there. I kind of just did that while we were talking. I put it over 1 just so I could see the denominator. That's always there, right? There's a 1 hanging out right here, even if we don't see it. So that one's good. That's represented. That's part of the least common denominator. We're good. And then if I look at the x plus 3, this needs to get represented in the least common denominator. There it is. I don't need another one. It's already represented. Now, if for whatever reason this had 2 x plus 3s, there was another x plus 3 right here, then yes, I would need to make sure that I add a second one, but we don't have that going on right here. Okay. So that's a very quick, go back, watch the previous lesson on the section on simplifying complex fractions. If you're looking for, how we did that so quick there, I call it the universal denominator. All right. So what am I going to do with this? I might rewrite this here just to get a little space to work, and we're probably going to scroll down the entire page here as this goes. So here's what's going to happen. I'm going to take this 3x minus 5 over x plus 3, and I'm going to multiply that by this LCD. So times x plus 3 times x minus 4. Okay, that's getting multiplied by this numerator. And just for right now, I'm going to just set it up. I'm going to do the exact same thing with the 2. Right now it's 2 over 1. Great, fine, we can leave it like that. I'm going to multiply it. I'm kind of going to write on, I'm worried about running out of space. I'm going to multiply that by x plus 3 and the x minus 4. Okay, I've got this plus. That's part of the equation. But now it's this one on the right that actually looks the worst, that actually ends up being the easiest to simplify. So I've got the 8 over x plus 3, x minus 4. But what we're going to do for the third time in a row is multiply the numerator by x plus 3 times x minus 4. Oh, kind of ran out of room there. You see that? That's x minus 4. Okay, so how does this work? What happens? I'm actually going to start with this pink one on the right. So on the right, here's what we have. This x, let's use a different color. This x plus 3 that we just kind of inserted is going to cancel out that x plus 3. This x minus 4 is going to cancel out this x minus 4, leaving us on the back end of this equation as 8. There's only the 8 is left there, plus 8. Okay. Now, so that one was awesome. The other two, not so much. These ones are not so good. Well, it's just going to take a little bit more work, just because we can go right here on the 2. So now I'm working with this one. What happens? Nothing really cancels other than the 1 that was kind of invisible to begin with, right? We said there was a little 1 right here, would cancel with this 1, but nothing real cancels out here. So I'm actually going to have to multiply 2 times x plus 3 times x minus 4. So this is one, stay organized, and FOIL or box method, however you would do it, okay? Let's take a look. So I'm somebody, like me, for me to multiply this, I would say I'm somebody who's going to do the x times x first. So I'm going to keep track of this all right here. X squared minus 4x plus 3x and minus 12. Okay, I'll combine these middle terms here to get an x squared minus x minus 12. And then on that one, don't forget there was still this 2 that was hanging out front that I'm going to need to distribute in there. So that 2 that looks so nice and neat and clean, that ends up probably being the toughest one to simplify. Not that that's that tough, but there's just 2 different things. There's a FOIL and then a distributive situation. So I'm going to actually bump down another line here and say, here's where we're at. I'm at 2x squared minus 2x minus 24. And then I'm going to just bring down that plus 8 because we're going to need to combine that eventually here as well. Okay. Far left, let's see what we're working with here. We've got this we get a little bit of a break where the x plus 3 and the x plus 3 should wash out. That's the whole reason behind what we're doing here, is to just get rid of the fractions at least. Okay. But as you can see, I'm still going to have a situation where I'm going to have to multiply 3x minus 5 times x minus 4. It's a second FOIL situation. There's not really a shortcut way to do it. So what's 3x times x? 3x squared. What's 3x times negative 4? Negative 12x. What's negative 5 times x? Negative 5x. And negative 5 times negative 4 is positive 20. I'll combine my like terms here and end up with 3x squared minus 17x plus 20. Look at all that. Whew. And we're not even done yet. I mean, that's a big part of it, but we still have quite a bit of simplifying to go. The advantage there, why did we do all that? We're at least kind of on one single level here. No more fractions. I think you'll see once we combine all our like terms, we're going to end up with something that's going to need factoring, I'm guessing, to solve here. Let's do this. Get a little space to work here. I think the first thing I'll probably do, so here's the finish now. I think on this side, just getting these together as negative 16, negative 24 plus 8 is negative 16. But then now I'm going to bring everything to the left side. So let's do it one at a time here. I'm going to subtract a 2x squared from both sides. Okay, that's going to leave us an x squared, which I like. This is gone. I'm going to what? I'm going to add a 2x to both sides. That's going to leave us a negative 15x. And then here to get rid of the 16, I'm going to have to add a 16 to both sides. Cancel, cancel. Plus 36. And here we sit, and Mr. Crowell's got his fingers crossed because he's hoping he didn't lose track of a negative or a minus or something here. And we're left with something we can factor. Usually if you get here, and you're looking at something that, man, I can't come up with a combination that multiplies to this, that adds up to this. It's probably a matter of something happened. We lost track. Look at all that, along the way of like a minus sign or something like that. Okay. I think we're okay here. Let's see. While I'm talking, I'm kind of like mentally doing this in my head, to see if I can come up with that combination of numbers that multiply to 36, that add up to negative 15. I'm thinking 12 and 3. Can we make the signs work? 12 and 3 definitely multiplied. I guess in this case, they would both have to be negative. Let's see, negative 12 times negative 3 positive, negative 12, negative 3, negative 15. Awesome. So we're factored now as x minus 12, x minus 3 equals 0. All right, my sign's good there. I think so. So my solutions potentially here are 12 and 3. Holy cow. Did we get there? 12 and 3, the opposites. Let's check it out. Let's at least take a look. 12 and 3 going all the way back. Look at all that pretty color there. We are good. That 3 makes me a little bit nervous, but I didn't catch anything along the way. A negative 3 would not be a solution here. Even if it showed up, I'd want to make sure I take it out because right away I can tell negative 3 gets plugged in right there. That's going to create a 0. And if a negative 3 gets plugged in right there, it's also a 0. Okay, so that wasn't one of our solutions. I don't think we have to take any of these out. Both 12 and 3 should work. And I'm getting the built-in hint there where it says solve a rational equation with 2 solutions. Yeah, so it is okay to leave those. They're both going to check when we plug in. This one is tough to check. It's not one, short of me getting on the calculator and plugging in a 12 here and doing this division, seeing what you get, maybe jotting down the decimal, and then saying, all right, I'm going to repeat the whole thing over here, plug in the 12 here and here, 8 divided by that multiplied plus 2, we're going to end up with the same decimal value or whatever value, maybe not a decimal, but same value on both sides of the equation. So still checkable end of a test, definitely something you should look at doing, but probably not something you're doing on a problem-to-problem basis. If you take care of your operations there, and it factors cleanly, you're probably on the right track. All right, last one. All right, it's similar. And this is a great look for us. I'm just obviously going to do it in the video because the built-in hint here is we're going to see. I'm guessing one of my solutions that we're going to work out to is going to be negative 4 or 4, just because it's mentioning. Now, obviously, I'm not going to tell you on an assessment. Is there an extraneous solution or not? But likely something like that's going to happen here. Okay. All right. What's the deal? What's the first move? Right, cross multiplying is not looking great here. Even before I start doing some of this LCD stuff, right? That's kind of the game plan here. I think with the situation when we can't cross multiply, it's hard for me to tell just looking at this x squared minus 16. Should I be including that as part of my LCD? And the answer is no, right? So even before we do anything with LCD is we got to factor. We should factor this. So this is one we've seen again fairly recently. I would say. If you need help there, that's probably something we look back at. But that's a difference of squares pattern. X squared minus 16 is difference of squares. That's going to be x plus 4x minus 4. All right, that's a little bit better. So now again, when I look, it's I shouldn't say always, but it's not a bad idea to start with your biggest, nastiest looking denominator, right? So right here, there it is, x plus 4, x minus 4. And just say like, hey, for the same reason, like both of those have to get represented in the LCD. And then just go denominator by denominator and say, all right, is there another just single x plus 4 there? Yes, it's already represented. X minus 4, yep, it's already represented. So this is just, that's what we're going to use for our LCD. And the other thing, the other approach, maybe the other mindset is just like, I'm struggling with this LCD stuff. Just think about what has to be in the numerator here to get some canceling going on. Yeah, an x minus 4 would be really great to have in the numerator. An x plus 4 on this one would be really great to have in the numerator. An x plus 4 and minus 4 is going to be awesome on this one because we're going to get full cancel. So maybe just a different kind of way to look at it. All right, here we go. Let's do it. From here, it's very, very similar. So I'm going to kind of build it in as we do it. The original fraction is 6. I'm going to start way on the left here. 6x squared over x plus 4, x minus 4. Handwriting's getting a little bit smaller because I know we're going to try to squeeze in all this other stuff. X plus 4, x minus 4. Okay. All right. Next, now this one's got a subtraction. We still have to like watch the operations here. This might be something, well, I guess we can do it once we multiply it out. But here's my original 3x over x plus 4. And we're multiplying that by the LCD. So up top, we're getting a what? X plus 4, x minus 4. And then last but not least, jump into the other side of the equation. We've got 4 over x minus 4. Same deal, x plus 4. So I do take the time. I know there's people that just like that are going to want to just start canceling stuff right away. They're going to say, oh, I don't need to write all that out. I'm going to get rid of the x minus 4s over here and just write the 4x plus 4. That's fine. You're not necessarily like breaking any rules or anything like that. I just worry sometimes losing track of stuff. And, that's sometimes where we make our mistakes. Okay, I'm going to start on the left here and just work it left to right. So what happens? Plus 4, minus 4, minus 4. Awesome. This leaves us a 6x squared just hanging out by itself. Next one. The plus 4s are going to drop out, but I still have to multiply now this x minus 4 with this negative 3x. And actually what I can do here is just assign the negative to the 3x like that. And just it'll take care of the signs when I distribute it. Okay, so what do I get here? I get negative 3x times x, which is negative 3x squared. That was the first multiplication. And now I'm going negative 3x times negative 4, which is positive 12x. Okay, similar here with what's on the other side of the equal sign. So I'm going to leave this here. We're going to get what? We're going to get a cancel with the minus 4 this time. And it's a little bit simpler with the distributive. It's just distributing a 4. So 4x plus 16. Okay. Let's do it. I'm not liking the way this is looking with the factoring, but we're gonna press on. Let's bring everything over to the left side. Okay. So we're going to subtract a 4x. (6x squared), there's nothing to combine with. I'm going to get a negative 7x right here. And then we'll subtract, whoops, wrong spot, sorry. Got to start all the way over there. That's what I was getting a little bit nervous about, but I wasn't paying very close attention. I'm actually going to bring these two together here. So sorry about that. 6x squared minus 3x. That's a 3x squared. Okay. Now what can we do? I'm going to subtract a 4x from this to get 8x right here. And then the 16, as long as I'm not losing it here, we don't have anything to bring over or combine with it. So on the left side, that's where we end up. I think we're going to be okay here, but still, of course, our last example, last chapter, ends with a little bit of a tougher factor here. So what makes this one tough? We've seen it recently, reviewed it. 3 times negative. I'm looking for two numbers that multiply to 3 times negative 16, which is negative 48. And those same two numbers should multiply to 8. Or, I'm sorry, add to 8. Yikes. Okay. And this is where I'm rolling through factors in my head. 12 times 4. Yeah, sure. I like that one. 12 and 4, right? Because 12, 24, 36, 48. 12 and 4 get me to 48. If it's a negative 4, that's going to give us a negative 48. That's going to add up to positive 8. We're good. But what makes this one the tough factor? Here it is. We come back. We bring the 3x down with us. I take these two numbers, give them an x. So a 12x and a negative 4x. And then I'm going to bring the negative 16 down with us. Hopefully you're still with me here. We're not done yet. We're getting close, though. What's left? I'm going to factor by grouping. Group the first two terms, group the second. Don't lose track of that negative that was sitting right there. Take out as much as we can from the 3, the 12, and the x's. So I can definitely get a 3x out of here, leaving us an x plus 4. This is the one I reverse engineer and say, hey, I know this has to be x plus 4 here. What has to come out to make this x plus 4? It's actually going to have to be a negative 4. Quick double check. Negative 4x, negative 16. Sure. Here's where we put it all together now. 3x minus 4 gets its own binomial. 3x minus 4. And then I just bring one of the x plus 4s down with us here. Equals 0. Now we're factored. Still not completely done. It's what are the solutions, right? It said solve the equation. So when I look here, this one's a little more obvious right here. What makes that equal to 0? Negative 4. This one, if this one doesn't jump out at you, I always say just set it equal to 0. Mathematically solve for x. So you'd add a 4 to both sides and divide by 3 to get x equals positive 4/3. That's some scroll in there. Now, if you're in your notebook, it's a different story. But we got quite a bit there. Negative 4 and 4/3. So now I come all the way back up. And I go back to my original original equation, essentially here, and say, all right, I just want to look at you. We said we're thinking x equals negative 4 and positive 4/3. I think that's what we said. Yep. So again, you're getting a little bit of a hint here. I'm getting the hint. I'm taking it that we were thinking we're going to be extraneous. It's this negative 4, right? We talked about it a couple different times. Right here, all it takes is one spot. If I plug in a negative 4 right here, negative 4 plus 4 is 0. You can't have a 0 in the denominator of a fraction. So we have to eliminate that one from our solution set. So when it completely shakes out here, this 4/3, that's going to be a beast to check. Right now, I know that's the right solution, but on your checks, I would essentially just go one at a time. That's probably the easiest thing to do is on your calculator, 6 parenthesis 4/3 squared divided by parenthesis 4/3 squared minus 16. And even there, making sure you're putting probably parentheses around your denominator and stuff like that, and just seeing what you get, like jotting down maybe the decimal value you get, subtracting, starting over, 4/3 going in here, 3 times 4/3 divided by 4/3 plus 4. What do you get when you subtract those? Finally, hopefully that works out to the exact same thing when you plug it in over here. But again, that is nasty to check, especially being 4/3 and not like 2 or something like that. So that is the correct solution, or that is the only solution. X equals, maybe we'll put it down on the bottom just to make sure that nobody thinks we're keeping them both. Sometimes people just scroll to the final answer. We removed that one, and we just said x equals 4/3. So where did we start, right? It ended up being, wow, a little cross multiplying. That's pretty easy. Kind of picked up with that a little bit difficulty wise. Saw some easier ones. The last two were no joke as far as getting using that LCD. But that in a lot of cases, that's our only option, or maybe our best option. You could do some stuff with adding these as well, but okay, no reason to keep dragging it out here. We've solved cross multiplying. We use the least common denominator. We hit it all. We can solve rational equations. That's all I got for you. Yeah, I'll see you in the next lesson.